Alrighty guys, so we're going to go into, again, I know it says chords and arcs. We've done a little bit with arcs. Now we're going to do some more with it. So to get started, we have some theorems. So the first part of that theorem says that congruent central angles have congruent chords. Congruent chords have congruent arcs. Congruent arcs have congruent central angles. Chords equidistant from the center are congruent, and congruent chords are equidistant from the center. So some of these go hand in hand together. It's the opposite of each of them. That's why I just put them all in one slide. So remember, if you need to pause to get all this stuff written down, please do so, because I'm going to go through this not quick, but I'm not going to give you all this time, so hit that pause button. Alright, so what is the value of A in the circle below? So I'm trying to find this chord. Well, if we go back to some of those theorems, chords equidistant from the center are congruent. That's the one I want to highlight right there. Ooh, that was real good. Well, if these are equidistant, because this chord is the same length away from my center as this chord, then they must be equal together. Well, if this piece is 12.5 and this is 12.5, A is simply 12.5 plus 12.5, which gives me 25. Theorem part 2. In a circle, a diameter that is perpendicular to a chord bisects the chord and arcs. A diameter that bisects a chord is perpendicular to the chord. And the perpendicular bisector of a chord contains the center of a circle. Why do we care about that? Because it allows us to do all of these problems. So essentially what this is saying is it creates a right angle here, which means I now have a right triangle. If I'm trying to figure out what these are, it's telling me it bisects, so that means that this has to be 7. So I know that 3 squared plus 7 squared is r squared. 9 plus 49 equals r squared. I get 58 equals r squared. So r is equal to 7.62 centimeters. Go ahead and try this second circle. So go ahead and pause it real quick and do those operations. Should get 10.2. Alrighty, this next one. Well, we need to determine what my values are. Well, we said here, down here, that when it hits a chord as a perpendicular line, it bisects it. So it means this is 8, and this is 8. And then this here is the diameter. If I only want to use a radius, or half of that, then this also must be bisected. So this is 10 and this is 10. So then I have 8 squared plus x squared is 10 squared. So 64 plus x squared is 100. X squared is 36. So x has to be 6. And that one didn't have any units of measurement, so we don't add any on that one. Now, this one looks a little tricky, but isn't this just essentially a radius? isn't that purple line also another radius? So couldn't I say that that purple line I drew in is just x? And if this whole big thing down here at the bottom is 22, this has to be 11. So that means that 6 squared plus 11 squared has to be x squared. So 36 plus 121. So 157 is x squared. So then x must be 12.5. So yes, today's notes kind of went quick, but we needed to learn all of those theorems in order to do this stuff here on the board. Have fun doing your homework.